My dear friends, welcome to Rajshekhar classes on applied data science with Python. This is lecture number 497. In this lecture, we will try to understand advantages and limitations of DBSCAN. So now let's understand where does DBSCAN work well and what are its limitations and advantages. We are using the same slides that we are referred earlier. Imagine if this is my original data. So what I have as my final clusters, what is this whole brown points, this whole brown points that we see here as one cluster. This is, let me say, C1. All of these points, let me say, cluster, second cluster. These points as third cluster. These points as fourth cluster. These points as, I can say, it's a fifth cluster. This one is sixth cluster. And the rest of these blue points are noisy points or noise points. So one thing is quickly notice is the DBSCAN works. Just see, the DBSCAN works. The DBSCAN works very well, and it is resistant to noise. It is resistant to noise, isn't it? The name itself has noise, which means it handles noise. This is one of its biggest advantage, and you can handle clusters of different sizes. It can handle clusters of different sizes and shapes. This shape is completely different from this shape, isn't it? You can handle them very, very well. So to understand more advantages of DBSCAN, of DBSCAN, let's go to the Wikipedia article where there are lots of advantages. So DBSCAN does not require to specify number of clusters. DBSCAN does not require to specify number of clusters. This is a big advantage for DBSCAN. You don't have to tell number of clusters, just like in k-means. You can get arbitrarily shaped clusters, as we just discussed. It's very, very robust to this. You will get arbitrary shaped clusters. It is robust. It is robust to outliers and noise. You just have two parameters. What are min points and epsilon. These min points and epsilon can be set by domain expert, isn't it? Min points and epsilon can be set by domain expert. DBSCAN is designed for use with Oracle. It's designed for use for Oracle, MySQL, SQL databases, and they have special data structures for range queries. They have special data structures for range queries and regional queries. So these are some of the advantages. Now let's go to limitations of DBSCAN. This is very nice. This is very nice case where DBSCAN fails miserably. Suppose I have data set. This is my suppose I have data set. Let's look at this. Suppose I have data set with different densities, isn't it? This region has very high density of points, and this region has very low density of points. This region has again very high density of points. This region also has very high density of points. Now I choose my min points equal to 4 and EPS equal to 9.75. I would get my clusters as follows. Just see, I would get clusters as follows. This is cluster 1, let me say cluster 2, cluster 3, something like that, isn't it? I would get my clusters as follows, for which values? For min points equal 4 and EPS equal 9 points. All these points are, this is cluster, let me say points are in cluster 1, isn't it? This is C1. Actually what we are this is C1, this is C2, this is C3, but actually what we are expecting this one, C1, C2, C3, C4, C5, like this. This is one cluster, this is one cluster, another cluster, like this, isn't it? But what happened? But we are getting like this, isn't it? But what happened? All these are what happened? All these are grouped, isn't it? All these are grouped together. It's not really that bad if I keep min points equal 4 itself and epsilon equal to 9.75. Very small change. Let me change my let me keep min points equal 4. Let me keep epsilon equal 9.92. A small change, very small change. Earlier value is 9.75. Isn't it? Small change in my hyperparameter epsilon, and I get a completely different clusters. Now just see, I have got completely different clusters for small change in epsilon. So I will get clusters like this. I will get for small change of epsilon, for small change of epsilon, I am getting different clusters. Small change of epsilon, isn't it? I get a completely different cluster. So I will get clusters like this. My first cluster, let me say this is cluster C1, this is cluster C2, cluster C3, cluster C4, something like this. My first cluster, what it says, my first cluster C1, C2, C3, I can say like this. Let me repeat. This is my first cluster. Yes, this is my second cluster, this is my third cluster, this is my fourth cluster. And if you observe, first cluster C1 and second cluster C2, third cluster C3 and fourth cluster C4. So my cluster output has changed dramatically. That is important. Even when there is a small change in epsilon. Earlier epsilon value is 9.75. Now I kept it as 9.92. For the small change in epsilon, we are getting different clusters. So what happens is, when you have data which contains varying densities, your data set, here you have high density, low density, high density, like that, varying densities, isn't it? Varying densities, because this region has a high density. This is the medium. This is a medium density. This one is low density area, because you have only one set of parameters which are min points and epsilon. They define everything about shapes, isn't it? If your data set has multiple densities or varying densities, DBSCAN tends to fail or tends to not work very well. The other limitation is it's very sensitive to sensitive to your hyperparameters, isn't it? Which hyperparameter? If I change small change in epsilon, it is completely changed, isn't it? It is extremely sensitive to hyperparameters. If you change hyperparameters slightly, your whole outcome might change when you have high dimensional data. If you are using metrics like Euclidean distance, you will easily go into the problem of curse of dimensionality, and some of these techniques are densities may not work very well when you have high dimensional data. So your DBSCAN is not very well suited especially for high dimensional data like your text data. It may not work very well. Having said that, let's look at some nice examples. By the way, these examples are from actual DBSCAN research paper. Let's look at these two examples. So in both these examples, I have min point set to 4. Just see what is my min points value. Just observe this one. This min points 4. Here the epsilon is 0.5, and here for this, just see this one. For this one is epsilon. We are changing epsilon values. For this, epsilon is 5.0, isn't it? For this epsilon is 1 second. Yes. what's happening here? I'm keeping min points is 4, epsilon is 0.5. Here I am keeping epsilon is 0.4. You are getting different clusters, isn't it? Min points is set to the same value. This epsilon set to 0.5 here for figure A and 0.4 for this one, isn't it? By changing epsilon slightly, my whole cluster will change. See, this whole thing is one cluster. This whole thing in one cluster. This is other cluster, and this is other cluster. This is other. This is this is another cluster. Within this, just if you observe this one, within this there are different areas of density. Within this cluster there are some regions which are dense, some regions are sparse, extra. Because of this varying densities, by changing my epsilon slightly, I got completely different results, which means my DBSCAN is extremely sensitive. My DBSCAN is extremely sensitive to hyperparameter epsilon. Just I change little bit. Just see, min points is same, but here epsilon is 0.5, here epsilon is 0.4, isn't it? Another very interesting example, I have my min points is, let me consider one more example. Just see this one. Here also min points is 4, here min points is 4, here epsilon is 5.0, epsilon is 3.5, epsilon is 3.0. I have my min point is 4 because look at this. This is two-dimensional, isn't it? You are typically choose min points equal 2 into d. Here d equal to 2. 2 into d means min points equal 2 into 2, 4. The rule of thumb says that min points equal 2 into 2, that's 4. Now, here my epsilon is set to 5, my epsilon is set to 3.5, 3.0. But changing the epsilon, I am getting completely different clustering results again, which shows the fundamental limitations of DBSCAN, which is sensitive to parameters. Now let's go to Wikipedia and see what are the disadvantages. It's not entirely deterministic, of course. It is not entirely deterministic. Of course, this is like boundary case, but the more important case is it depends on the distance measure, especially when you are using Euclidean distance, especially for high dimensional data. You will get the problem of curse of dimensionality. You will get problem of curse of dimensionality, and if you have data sets with large differences in densities, it will not work very well. If the domain expert does not understand data very well and scale of the data very well, setting the right threshold min points and epsilon may be hard. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.